Hello, welcome again. We are solving questions from thermal engineering. The topic is IC engine, gas turbine and compressor. Question number 19 is a mechanic has an engine from 1970 model car which works on the basis of Otto cycle. The engine displaces 1.8 liters, has a compression ratio of 10.2 ratio 1 and has 6 cylinders. The the pistons in the original engine are 120 in diameter. The mechanic bores the cylinder and replaces the piston with a new pistons that are 2 larger in diameter than the originals. Keeping all other factors same, what will be the percentage in percentage change in power output? Option A 3.25%, option B 4.15%, option C 6.25%, option D 5.7%. Okay. So initial diameter is 120 and new diameter is 122 and the compression ratio depends upon the length of the stroke as well as diameter as well as diameter in the clearance space and piston travel remains same, so it is only dependent upon the length of stroke. Okay, so compression ratio in both cases, uh, that is in first case the diameter is 120 and in other case the diameter is 122 will remain same. Okay, because length of the stroke hasn't been changed, so work done will be as work done is mean effective pressure and multiplied by swept volume. So as PM also remains same because all the factor remain same. Okay, so PM mean effective pressure is also same. So length of the cylinder and length of the stroke remain same. Okay, but only the diameter has been changed. Okay, so percentage improvement in efficiency is here because work done is directly proportional to swept volume. So percentage improvement is efficiency will be uh, new volume minus initial volume divided by initial volume. So new volume is now directly proportional to diameter square because length is same. So now the diameter is d1 square and initial diameter was d square. So percentage is d1 square minus d square by d square or 1 new diameter is 122 and previous diameter is 120. So 122 square minus 120 square divided by 120 square or it will be 0.0336% or 3.36%. So answer is option A. Next, which has which gas power cycle consists of four processes during which work alone is transferred during processes and heat alone is transferred during other two processes? Option A Atkinson cycle, option B Carnot cycle, option C diesel cycle and option D Otto cycle. So in all the processes at, there is sorry in all the processes the work is also done during heat addition. Okay, so but here in Otto cycle there are two constant volume heat addition, heat addition and heat rejection process. So work is not done during the heat addition and heat rejection. Okay, so it means the work is transferred only during two processes, that is isentropic compression and isentropic expansion. So answer is option D. So explanation is in Carnot diesel cycle work is also transferred during heat addition. Okay, whereas in Atkinson cycle work is transferred during heat rejection, but in Otto cycle work is not transferred during heat addition and heat rejection. So as they are constant volume processes, so work is done during isentropic processes only. Okay, so which is uh, in which no heat is transferred. Okay, so answer is option D.